Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Calculus 12 content. And today we're going to move on to the product rule. So with that, let's get started. Okay, so here we are. So I wrote down product rule at the top. So what we're going to do is try just a couple of examples first, something really simple. So I have P of X equals 3, X minus 5, and X squared plus 1. Okay, so what we're going to do first is I'm going to write down the formula for the product rule. So whenever you indicate that you're taking the derivative, you have to put this line on top, which is known as prime. So P prime of X equals U prime V plus UV prime. So just like this. So what you're assuming here, so I know it's the product rule. I have two separate terms in brackets. We're going to assume that this whole first bracket, the 3x minus 5, is U. And the x squared plus 1 is going to be V. Okay, so let's go through this in a little bit of detail, and we're going to go through it really slowly. So first, what you're going to do is I see the U prime is you're going to take the derivative of the 3x minus 5. Okay, so remember on top of this x is a 1, so you're going to do 3 times 1, which is 3. And the minus 5 doesn't have an x here, okay? So it's going to be 0. So the actual derivative of 3x minus 5 is just equal to 3. Then it says u prime v. So v means I'm just going to keep the second brackets the same. I'm going to put x squared plus 1. Okay, then we're going to go to the uv prime. So u means you're going to keep the u brackets the same. So we're going to put 3x minus 5. Okay. Then v prime means you're going to take the derivative of the second brackets, which is x squared plus 1. So remember the power rule. You're actually going to take the 2 down. Okay, and for the exponent of 2, you're going to subtract 1. So what we're left with is going to be 2x. Okay, is everyone good so far? So we're just substituting it into this formula here. Okay. And now we can actually expand out the brackets. So we're just going to open the brackets here. And we're going to put the like terms together. So we are doing here 3 times x squared. So 3x squared. And then you're going to do the 3 times 1. So plus 3. Okay, same thing with the second brackets here. I'm just going to multiply both of these terms by 2x. So we're doing 2x times 3x, so plus 6x squared. And then you're doing 2x times negative 5, so negative 10x. Okay, make sure you do just watch the signs here. All right. So now we can put our like terms together. I see 3 plus 6 here, 9x squared. Oh, actually, we'll put the negative 10x plus 3. Okay. So this is a negative. We do want to put it in order here, okay? So my final answer is 9x squared minus 10x plus 3. Okay, you can always check your answer algebraically, okay? You can actually substitute back into that original equation, okay? And you should get the same answer as well. And how you can actually check your answer is just like expanding out this original bracket here. And you should still end up with this expression at the very end. Okay, so sometimes the question might say check your solution algebraically. Okay, is everyone good there? So let's try one more question here. Okay, so let's try this one. So I see, let's use P of X equals 2x plus 3, okay, in one bracket. And we'll do 1 minus x in the second bracket. Okay, P of X or y equals, it doesn't really matter what the function is, okay? What is important is that you recognize that this is the product rule. So we're going to do P prime of X equals U prime V plus UV prime, like this. Okay, so this whole first bracket is going to be U, and the second bracket is equal to V. Okay, so the first time you're going to take the derivative of 2x plus 3. So 2 times 1 here, which is 2. I always put it in brackets, okay, so you don't get confused. And then you're going to keep v the same. So it's 1 minus x. Okay? Then you're going to the second part of the equation here. Okay? It says u v prime. So u is, you're going to keep the u bracket the same. So 2x plus 3. And then we're going to take the derivative of the v here. So this is actually negative 1 on the x times 1, which is negative 1. Okay? And you see how it says 1 minus x here? Because the 1 doesn't have an x related to it, the derivative of that is going to be equal to 0. Okay? So now again, we're just going to open up our brackets. Okay, so we're doing 2 times 1 here, which is equal to 2. And then we're doing 2 times negative x, so negative 2x. Let's go to the second bracket here. We're doing negative 1 times 2x, negative 2x. And then you're doing negative 1 times 3, which is equal to negative 3. So you notice once you substitute it into the equation, all you're doing is just expanding and simplifying the expression. Okay, so we can put our like terms together here. Okay, I see negative 2x, negative 2x. This is negative 4x. Okay, and then you are doing the 2 minus 3, which is negative 1. And that's my final answer there. It's negative 4x minus 1. All right, and this is how you're actually like using the product rule. So with that, we're going to do a question that is slightly different. We're still going to use the product rule, okay? What we're going to look for is the equation I'm going to put of the tangent, okay? So remember the tangent line, okay, is the line is basically a straight line and it's only touching one point on the curve itself, okay? So I'm going to give you an expression here. Let's try this one. So I have y equals x squared minus 1 inside one bracket. The second bracket is x squared minus 2x plus 1. Okay? As soon as you have two brackets like this, okay, you know that you have to utilize the product rule. So the question says, determine an equation for the tangent line to the curve of this, which is the equation given, at x equals to 2. Okay, so I'm going to put x equals 2. Use technology to confirm your solution. Okay, now if you don't have a graphing calculator, you can always go online, okay, if you want to just check your solution. So what we're going to do is find the derivative. So you see how this is equal to y. In the Leibniz notation, I can also write dy over dx. Okay, so one more time, we're going to do u prime v plus uv prime. And I always write out the formula first, okay? Just so you don't get confused, okay? There shouldn't be any small mistakes here. So the first time we're going to take the derivative of the first bracket, u prime, bring the 2 down. And for the exponent of x, we're subtracting 1. Then you're going to keep the v the same. So write it right beside it. So x squared minus 2x plus 1, okay? We're going to go to the second part of the equation. We're going to keep u the same. This is u right here. Let's put it on top. And this is v. So the u stays the same. So I have x squared x squared minus 1 here. Okay. And we're going to keep that the same. Then you're going to take the derivative of the second bracket. Okay. I notice the expression is slightly longer. Again, bring the 2 down. So 2x, because it's 2 minus 1 for the exponent. And I notice the second term also has x. So you're going to do negative 2 times the exponent on top, which is 1. So you're doing negative 2 times 1, which is still negative 2 here. Okay, everyone's okay here? So in this case here, because we're looking for the equation of the tangent, okay, there really is no need to simplify this expression to calculate the slope, okay? So what is quicker is we're going to just substitute our x equals 2 into this expression. So I think I'll write maybe like one step here. So it's 2 times 2. We're doing 2 squared minus 2 times 2 plus 1. Okay, so just like this. And most teachers do want you to show at least one step, okay? Just so they can see that you're substituting it in. So let's go to the other brackets here. This is 2 squared minus 1. And in this bracket here, it's 2 times 2 minus 2. So just like this. Okay? You're going to put this into your calculator. And I see that we're getting 10. Okay? If you feel like showing your steps here as you're doing the expression, that's fine as well. Okay? Now we notice that we have, so when you're taking the dy over dx, the derivative, this is basically the slope, okay, of the tangent. And that's what I have so far. So the next step is going to be, okay, you're substituting in x equals 2 into the original equation. Okay, so let's write it as like y equals, I'll put f of 2. So the reason you're substituting the x equals 2 into the original equation is I need the actual point. Okay, so we're going to sub it into this equation right here. Okay, so I'm going to write it right here. So it's 2 squared minus 1. Okay, in the first bracket. In the second bracket, we're going to do 2 squared minus 2 times 2 plus 1. Okay, so just like this. Everyone's good? Put into your calculator here. Okay, or if you want to just like show your work, that's fine. This is 4 minus 1, which is 3. Okay, and this is 4, 2 squared, minus 2 times 2, which is 4. So you see that it just like cancels out and you're left with 1. So it's like 3 times 1, which is equal to 3. Okay, so basically what you're using is the tangent point. Let's write that here. I have my tangent points because I have my x value, which is 2, and the y value is what we solved for right here, which is equal to 3. Okay, everyone's all right? So this is going to be, so maybe we should like number our steps here. Okay, so this is step 1, where we found the slope. This is step 2, where we found the actual tangent points. Okay, and we have enough space right here. In step 3, we're going to put it into the equation of y equals mx plus b. So if you do remember from previous years in math, when you do substitute into the y equals mx plus b, because it's a straight line, I notice all I need is basically the slope, which I have here from step 1. And I need at least 1 point in order to find the equation. Okay, so we are going to just substitute. Let's substitute our slope. Our slope is 10. So do y equals 10x plus b. Okay, and then we have our tangent point. So I'm going to write it right here. So the point is 2 and 3. And we just want to substitute the x and y into this equation. Okay, so the y is equal to 3. So we're going to do 3 equals 10 times x, and the x is 2 plus b. So just like this. So I have 3 equals 10 times 2, so 20 plus b. We're going to take the 20 to the other side. B is equal to 20 minus 3. So we see b. Oh, I'm sorry. So we're going to actually write it the other way around. Okay, so I'm going to put actually 3 minus 20. Okay, so if you're thinking that that doesn't make a difference, it actually does. It's a difference in terms of the sign. Okay, so 3 minus 20 is negative 17. Okay, and if you did 20 minus 3, it would be positive 17. So your answer would be incorrect. Okay, so we have the value for b now. And put therefore, our equation for the tangent to this curve is going to be y equals 10x, which is the slope, and then minus 17, which is the value of b. And that's actually the y-intercept. Okay, so if you remember from previous years. Okay, so this is my equation. So notice, very simple. They'll give you the actual like function here. Okay, the first step was we're finding the derivative, and we're substituting the x value that they're giving to us so we can find the slope. And I notice here in the second step, we substituted f of 2, which is the x equals 2, into the original equation, and that way we can actually find the tangent point. And then once we have the slope and we have the tangent point, you can take that and you can sub it into the y equals mx plus b. And that is going to give you the value of b, which is the y-intercept. All right, and once you have the y-intercept, you can see that you can just obtain your final equation here. And in this case, we got y equals 10x minus 17. All right. So I think one thing we should remember about the product rule is the actual formula, okay? This is the formula right here. It's u prime v plus uv prime. And in the next video, what we'll do is actually just review getting the derivative of the normal polynomial functions, so everyone is good with that. All right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.